Well, welcome back to the NAWT homework, and here is problem number 4. So again, we're working on a pump tank, and so the first thing we're going to do is calculate the gallons per inch. That's going to be the length times the width times 7.5 divided by 12, which is going to be 49 divided by 12 times 68 divided by 12 times 7.5 divided by 12. Doing the math then, 49 divided by 12 equals 4.1. 68 divided by 12 equals 5.7. 4.1 times 5.7 times 7.5 divided by 12 equals, I made a mistake there, so I'm going to go back and do it again. 4.1 times 5.7 times 7.5 divided by 12 equals 14.6 gallons per inch. If the pump is turned on for 3 minutes and the effluent levels change from 66 to 73, what is the pumping rate? Well, the gallons per minute is going to equal the dose divided by the time. The dose is going to equal the change in inches times the gallons per inch. So it went from 73.5 to 66, so that's the change, times my gallons per inch, which is 14.6. So that's going to equal 73.5 minus 66, which equals 7.5, times 14.6, which equals 109.5 gallons. My gallons per minute then is equal to the dose, which is 109.5 gallons, divided by the time, which in the problem is 3 minutes. So it's operating at 36.5 gallons per minute. If it has a check valve and the required dose volume was 75, how long should the timer be set for the on setting? The on setting is equal to the dose divided by the gallons per minute. It says that I want a dose 75 gallons divided by 36.5 gallons per minute. 75 divided by 36.5 is 2.1 minutes. It's a little high, and so because technically it was 2.05, so I rounded it to 2.1. If the number of cycles required was 6 times per day, how long would the off time be set? The off is equal to a day divided by the number of cycles minus the on time. A day is 1,440 minutes. You want it to cycle 6 times and minus 2.1. So 1440 divided by 6 minus 2.1 equals 100. Let me just try that one more time. Equals 237.9 minutes. If the timer was set to pump 6 times a day and the cycle counter read those numbers, is it working properly? Well, the max should equal 6 well, the number of days times the cycles, which is going to equal 120 times 6, which is a total of 720 cycles. So that's my max number. My actual number is equal to 3,442 minus 2,988. And so I do that, and that's 553 cycles. So right here, it looks okay. If the elapsed timer reads 215 hours on the last visit and this many hours today, what is the total recorded time? Well, the time would be present time minus last time, which would be 215.8 minus 119.6 hours. So 215.8 minus 199.6 equals 16.2 hours. Changing that to minutes, that would equal 972 minutes. Now, how many minutes should have been recorded? Well, the max minutes equals the max cycles times on time, and so that would have been 720 times 2.1, which would be 1512. So we're well below the max. The actual minutes, though, should have been the actual cycles times the on time, and in this case that would be 543 times 2.1, and that is 1140. And so that's okay that that is lower than the actual. This is just telling you that it didn't always run the whole time. What is the total flow? The total flow is the actual minutes times the gallons per minute. So that would be 972 minutes times 36.5 gallons per minute. So that was 972 times 36.5. And that equals 35,478 gallons. And then the average is equal to the total divided by the days. So that's going to be 35,478 divided by 120, which is 295.6. All right, so that's the end of that problem, and I thought that went pretty well.